So, the unit circle. This is a unit circle. The unit circle is a circle with a radius of 1 unit. So, any line from the center of the circle to the outside of the circle has a length of 1. And the unit circle is very handy for knowing for helping us find the sine and cosine of certain common angles. So, yes, you are going to have to memorize this. So we're going to work through some of the angles in the first quadrant of the unit circle. The good thing about the unit circle is that once you know the first quadrant, you know all of the others because it's symmetric. So all we have to do is memorize this first quadrant, and then we can just flip it over into all the other quadrants. So we're going to start with this angle. This is a 45-degree angle. So 45 degrees here. Here, they want you to write it in radians. So a radian, which we'll talk about more a little bit later, but a radian is another way of measuring an angle. And one circle, 360 degrees, is equal to 2 pi radians. So 180 degrees is equal to pi radians. 45 degrees is equal to pi over 4 radians. Always leave your radians in terms of pi. Do not give me decimal radians. So, radians here is pi over 4. Now, because this is the unit circle, the hypotenuse of this triangle is the radius of the circle. It's 1. 1 what? 1 inch, 1 mile, 1 something. 1 unit. And so, if we imagine this in a coordinate plane, and we draw a line straight down from the point where the radius touches the edge of the circle, we get a right angle with the x-axis. And so this makes a right triangle. Specifically, it makes an isosceles right triangle because we have two 45-degree angles and one right angle. If you think back to geometry, this means that these two sides are the same. If we know that these two sides are the same, and we know that the hypotenuse of this triangle is 1, we can use Pythagorean theorem to solve for x. So 1 squared equals x squared plus x squared. X squared plus x squared is 2x squared. Divide both sides by 2. 1/2 equals x squared. X equals the square root of 1/2, which is equal to the square root of 1 over the square root of 2, which is equal to 1 over the square root of 2. And when we rationalize that denominator, we get the square root of 2 over 2. So this side of the triangle is the square root of 2 over 2, and this side of the triangle is the square root of 2 over 2. Now, the length of this side is the y-coordinate of the point on the circle. And the length of this side, the base of the triangle, is the x-coordinate. So, our coordinates for this point on the circle, for an angle of 45 degrees, are both square root of 2 over 2. Yes, leave them in terms of the radicals. Do not give me decimals. So for a 45-degree angle, we get square root of 2 over 2. And square root of 2 over 2 for the x and the y coordinate. All right, so we get a triangle that looks like this. And our x and our y are the same, so let's make them both x. And we're going to, when we solve for x, we get that x equals the square root of 2 over 2. All right, let's look at this triangle. So this triangle is a 30-degree angle. So this is 30 degrees. Right? Remember, 180 degrees is equal to pi radians. So 30 degrees is equal to pi over 6 radians. So mark this angle as pi over 6. Again, here we know our radius is 1. And here we have an x and a y. Unlike with our 45, 45, 90 triangle, these two sides are not the same. So we can't do the substitution that we usually do. Or the substitution that we did for the last one. But here, looking at this triangle, if you recall from geometry, 30, 60, 90 triangles have a special relationship between the sides as well. And it makes more sense if we think of our 30, 60, 90 as being half of an equilateral triangle, right? So if this is an equilateral triangle, and all of these sides are the same, they're all equal to 1. When I cut this equilateral triangle in half, I get a 30, 60, 90 triangle. And now my y is 1/2. The original side was 1, I cut it in half, now it's 1/2. So now I know two sides, the lengths of two sides of this right triangle. I can use Pythagorean theorem to solve for x. So 1 squared equals 1/2 squared plus x squared minus 1/4 from both sides. 3/4 equals x squared. Take the square root. We're going to get that x equals the square root of 3/4, which is equal to the square root of 3 over the square root of 4, which is equal to the square root of 3 over 2. So, our y is 1/2, and our x is the square root of 3 over 2. So if I go back here, the y is 1/2, and the x is the square root of 3 over 2. Now, up here, this is a 60-degree angle. The 60-degree angle being here, this is a right triangle, means that this is a 30-degree angle. And we've already solved this one. We solved this one back here, right? The side opposite the 30 degrees is 1/2, and the side opposite the 60 degrees is square root 3 over 2. So now it's just that the x is 1/2 and the y is square root 3 over 2. They switch. There we go. And this angle is 60 degrees, and the radians is pi over 3. Twice as much as the 30 degrees, which was pi over 6. So now, put it all together, right? Our 45-degree angle is pi over 4 radians, and the x and the y are both square root 2 over 2. Our 30-degree angle is pi over 6 radians, And that has an x of square root 3 over 2, right? And a y of 1/2. Our 60-degree angle is pi over 3 radians. And that is the same as the 30, except we switch them. So the x is 1/2 and the y is square root 3 over 2. We also can do the 0-degree angle, which is 0 radians. And the x here is 1 and the y is 0. It doesn't go up at all, it just goes over 1. We also have a 90-degree angle, which is pi over 2 radians. And here the x is 0 and the y is 1. So that gives us one whole quadrant of our unit circle. Now, let's generalize this. So let me go and put in the stuff that we just said. That's pi over 4. And that's square root 2 over 2. Square root 2 over 2. So starting with this one. Actually, let me go ahead and put the axes. Right, 0 degrees, 0 radians. Coordinates are 1, 0. This is 90 degrees, pi over 2 radians. This is over 0 and up 1. This is going to be pi radians, which is 180 degrees. And this is an x of -1 and a y of 0. Those should be pretty straightforward. Now, our 45-degree angle, right? This is pi over 4. There's also an angle where this would be 45. We can make another 45, 45, 90 triangle here. This measure is going to be 135. It's the 90 degrees from here plus an extra 45. Gets us 135 degrees. The radians, in radians, that's 3 pi over 4. You can count them. Pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4. Because this also makes a 45, 45, 90 triangle with a hypotenuse of 1, the x and the y are going to be the same. They're both square root 2 over 2. We already calculated that. But because this angle is in quadrant 2, the x-coordinate in quadrant 2 is negative. Here we had our 30-degree angle, which was pi over 6, and had coordinates square root 3 over 2 and 1/2. So we have an angle here that's also 30 degrees. It's 30 degrees up from 180, so that's 150 degrees. And we can count this, pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, it's pi over 2, 4 pi over 6, 5 pi over 6. And then 6 pi over 6 would be pi. All right, so pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, and this would be 5 pi over 6, and then this is 6 pi over 6, which is pi. So you can just count in increments of pi over 6. Get your radians. Now, this is going to make a 30, 60, 90 triangle. It's the same as the 30, 60, 90 triangle we had over here. So it's going to have the same coordinates. Square root 3 over 2 and 1/2. But because it's in quadrant 2, the x is negative. And then this angle, right? This was our 60 degrees, which was pi over 3. And this is 1/2 and square root 3 over 2. We have this angle here, right? This would be 60 degrees. Makes this angle 120. And our radians would be 2 pi over 3. And it's going to have the same coordinates, except the x is negative. Ta-da! Now you have half a circle. Now let's do the whole thing. Start with the axes. 0 degrees, 0 radians. This is over 1 and up 0. 90 degrees, pi over 2 radians. This is 0, 1. This is 180 degrees and pi radians, and this is negative 1, 0. Another 90 degrees is 270 degrees, 3 pi over 2 radians, and this is 0, negative 1. And then we come back around, we also have 360 degrees and 2 pi radians. Still the coordinates are 1, 0 for that. Let's start with our pi over 4s, our 45 degree angles. So this was 45 degrees, pi over 4, and this is square root 2 over square root 2 over 2, square root 2 over 2. 45 degrees, pi over 4. 90 degrees is 2 pi over 4, which is pi over 2. The next would be 135 degrees, which is 3 pi over 4. And that is square root 2 over 2 and square root 2 over 2, except the x is negative. Add another 45 degrees, that's 180. 4 pi over 4 is pi. If we add another 45 degrees, we get 225 degrees. That's going to be 5 pi over 4. And that's also going to have the same coordinates. Except now we're in quadrant 3, so they're both negative. Add another 45 degrees, that's 270, or 6 pi over 4, which is 3 pi over 2. Add another 45 degrees, that's 315 degrees. That's 7 pi over 4. Coordinates are still root 2 over 2, root 2 over 2. Now we're in quadrant 4, the y is negative. And then we add another pi over 4, another 45 degrees, and we come back to 360 or 2 pi. So 8 pi over 4 is 2 pi. There's our pi over 4s. Do our 30 degree angle, right? Pi over 6. This has the coordinates, root 3 over 2 and 1/2. Symmetric across the axis, there's the 150 degree angle, which is 5 pi over 6. And that has the coordinates negative root 3 over 2 and 1/2. Reflect that over the y-axis. That's going to be 210 degrees, which is 7 pi over 6, and has the coordinates negative root 3 over 2 and negative 1/2. Same coordinates, but now they're both negative. Reflect that back over the x-axis. This is 330 degrees, right? 30 degrees short of our 360. and that's 11 pi over 6. Pi over 6 short of 12 pi over 6, which would be 2 pi, and has the same coordinates, root 3 over 2 and 1/2, except now the y is negative. And then we do our pi over 3's. This is the 60-degree angle, which was pi over 3, and has the coordinates 1/2 and square root 3 over 2. Reflected over the x-axis, another 60 degrees. This is 120 degrees. 2 pi over 3, and has the coordinates negative 1/2 and root 3 over 2. If we reflect that over the x-axis, right, we get an angle that is 180 plus 60 is 240 degrees. And that is 2 pi over 3. This would be 3 pi over 3, which is pi. This would be 4 pi over 3. And that's going to have the same coordinates, 1/2 and root 3 over 2, except they're both negative because we're in quadrant 3. We reflect that over the over the y-axis. That's going to be another 60 degrees. That's 300. Another pi over 3. That's 5 pi over 3. And that has, again, the 1/2 and the root 3 over 2, except the root 3 over 2 is negative. It doesn't really look like a 3. There we go. And that's your unit circle, right? It's all the same. As long as you memorize these, all you have to do is make it symmetric all the way around. It's not that hard. So, what is the point of doing the unit circle? Well, let's go back to one of our, let's go back to something where we had a triangle. Let's do this one. All right, so we've got a triangle here. This is the 60-degree angle. What is the sine of this 60-degree angle? It's going to be the opposite over the hypotenuse. The opposite side is root 3 over 2, and the hypotenuse is 1. So the sine of 60 degrees is root 3 over 2. The cosine of 60 degrees is going to be the adjacent over the hypotenuse. Adjacent side is 1/2. Hypotenuse still 1. Adjacent side, so the cosine of 60 is just 1/2. The hypotenuse on a unit circle is always 1. That's why it's the unit circle. So, for an angle here in standard position, the sine of any angle theta is going to be the opposite side, which in this case is the y, over 1. So sine of theta is the y coordinate of the unit circle. And cosine theta, the adjacent side is the x, so that's going to be x over 1, which is just x. So the x coordinate is cosine theta. So the unit circle tells us the sine and the cosine of any angle on the circle. All coordinates on the circle are in the form of cosine theta, sine theta, as an ordered pair. So if I ask you what is the cosine of 240 degrees, you find 240 degrees on the circle, and the cosine is the x. Cosine of 240 degrees is negative 1/2. Or if I ask you what is the sine of 315 degrees, you find 315 degrees on the circle, and the sine is the y-coordinate. So sine of 315 equals negative root 2 over 2. So this is a way that we can easily find the sine and cosine of some very common angles. You definitely, absolutely need to keep this in your notes at all times. A completed unit circle. You need to have it in class every day. And that's a unit circle. Tune in next time to see what sort of fun things we can do with it.